now we're going to look at factoring trinomials by grouping. So what that means is, you know how we start with something like x plus 1 times x plus 2, and when we FOIL and we combine like terms, we get something like x squared plus 3x plus 2. So now what we're going to do is we're going backwards. We're going from this form to the factored form. And we're going to do it by grouping. So let's look at the first one. We've got x squared minus 3x minus 28. And as we saw previously, when we're factoring this, we need to look at the factors of 28. And in this case, it's going to be negative 28, which means even when I write these out, one of them is going to have to be negative. So factors of 28 are 1 and 28, 2 and 14, 4 and 7. And I want to pick a pair so that when I make one of them negative and I add them together, I get negative 3. Well, if you look at our pairs of numbers, the only one that's going to give us negative 3 when I add them together and one's negative would be right here. So I'm going to rewrite my trinomial. I'm going to keep the first term the same, but now instead of negative 3, I'm going to put in the two numbers that I just found. I'm going to put in a positive 4x and a negative 7x. Okay, so I just replaced this with positive 4 and negative 7 because when I combine those terms, I get negative 3. Now I'm going to do what we were just doing before, which is factor by grouping. In the first two terms, I can take out an x. In the last two terms, I can take out, remember, I want to be left with x plus 4. So if I want to be left with positive x plus 4, that means I need to take out a negative 7. And I get x minus 7, x plus 4. Now you might be looking at this and saying, yeah, I knew that was going to be the answer because we got 4 and negative 7, and here they are, 4 and negative 7. And that's true as long as my coefficient right here is 1. As long as this coefficient is 1, as soon as you find these two numbers, you can just put them straight in. You don't have to do these steps, just put them right in. Now, let's look at one where the coefficient is not 1. So in this one, I notice that all my coefficients, oh, there's an r missing here. Just put it in. I notice that all my coefficients are even. So I can take a 2 out right from the get-go. So I'm going to do that first. I'm going to take out a 2, and I'll be left with 2r squared minus 11r plus 15. All right, now I'm going to do what I just did in the last one, but difference is I'm not just going to look at factors of this number. Like here, when I did 28, I just looked at factors of 28 because I just had a 1 here. But in this example, I have a 2 as my leading coefficient. It's not a 1. So I can't just look at this number. I have to multiply this one and this one together. Okay, you have to multiply both of these together. So when I multiply them together, I get 30. And I look for factors of 30. 1 and 30, 2 and 15, 3 and 10, 5 and 6. And again, I'm looking for a factor pair that when added together will give me a positive, will multiply to be positive 30, but add to be negative 11. So I think I found it. If I take this last pair and make them both negative, They will add to be negative 11, but multiply to be positive 30. So let's put them in. Now we split the middle term. I've got this 2 out front. I'm going to write 2r squared again, and this circled number, that negative 11, I'm going to replace with negative 5r and negative 6r. Now I'm going to factor by grouping. I'm going to look at my first 2 and see what I can take out. It looks like numerically I can't factor anything out, but with the variables, they both at least have an r, so I'm going to take that out. And I'm left with 2r minus 5. In the last set, I want to be left with 2r minus 5 again. So if I look at what I can take out, in order to be left with positive 2r minus 5, that means here, out of these two terms, I can take a negative 3. So now when this is fully factored, I would have 2, and then I would have 2r minus 5 and r minus 3. It doesn't really matter which one goes first. You can write the r minus 3 first if you like, but it doesn't matter because multiplication is commutative. Now, this down here says always use the discriminant to determine if something can be factored, and always check your answer by multiplying the factors.